Hey everyone, in this video, let's find the time and space complexity of this code. Okay, so this is the iterative code consisting of a for loop. Okay, and we have assumed that one basic operation, it takes 1 unit amount of time. Okay, so if you are not sure that what is the time and space complexity, then you can go to the video of the time and space complexity that I have made. Okay, so in that video, I have explained what do you mean by time and space complexity, and I have given you a good introduction of the time and space complexity. Okay, so you can find the link in the video description below. Okay, so now before beginning, let me tell you, I can write this for loop, okay, in this way also, as I am concerned with the only pseudocode, right? So I can write this way for I equal to 1 to n. This means this thing only, that is I is starting from 1 and it is running till n times, or you can say it is running less than equal to n. Okay, and every time we are doing I plus plus. Okay, so in short form we can do this thing also. As I have told you in the previous video that to analyze the iterative codes, we will use the frequency count method. So what is frequency count method? Again, I have explained in the previous videos. You can find the link in the video description below in the playlist of the algorithm course. Okay, in the frequency count method, we have to actually count the total number of times the statement which are having the basic operations, they are present, right? So basic operations are like plus, minus, multiply, divide, or less than, or the assignment. Okay, which actually takes 1 unit amount of time. Those are the basic operation. Okay, so that I have again explained in the previous video. Okay, so to apply the frequency count method, first we will find the frequency, total frequency of all these statements. Okay, and after that we will find the time complexity and the space complexity. Okay, let's find the total time taken by all these statements. Okay, let's find the frequency first. So here you can see in the for loop, you know that this statement will be executed how many times? This initialization will be done only once, right? So this will be done only once. Okay, so frequency of this operation will be 1. Okay, this will be done only one time. Now this I less than equal to n, how many times this line will be compared? So let's take a smaller example. If n is 4 and I is starting from 1. Okay, so basically I will go on till 4. 4 less than equal to 4, it is true, right? So basically these many number of times your I less than equal to n is true, but for the fifth time also, that is when I is 5, this statement will first go to the CPU and then 5 less than equal to 4, it will be false. Okay, but this statement is being compared, this is comparison is being done, right? So for n equal to 4, total 5 times I less than equal to n statement is being executed, right? So if the value of the input is n, okay, for general n, this statement will be executed n plus 1 time. How many times this statement will be, you can say, executed? The number of times this I less than equal to n, this will be true. That many number of times this statement will be executed, right? So this statement was true how many times? For n equal to 4, this was true for 4 times. So for n, this will be true for n times. Now one last statement that I have not written here by mistake is I plus plus. Okay, this is also a, like you can say, I equal to I plus 1. Okay, and we will consider this as one basic operation. Okay, so how many times this I plus plus will be executed? This I plus plus will actually be done 4 times for n equal to 4. Okay, initially I was 1, then I plus plus will make it 2, then it will make 3, then it will make 4, and then it will make 5. So total 4 times. Okay, this I plus plus was executed. So for value of n, this I plus plus will be executed n times. Okay, so basically if we count the total frequency, it will be 1 2 3 3n plus 2. Okay, so this is the total frequency of these basic operation statements. Okay, for these total statements, or for these total number of steps, okay, these are the total basic operation steps. Okay, how much time will be taken to execute these statements? So basically if one step take 1 unit of amount of time, so for these steps it will again take 3n plus 2, you can say, unit amount of time, right? And for our further discussion also, we will assume that one step takes 1 unit amount of time. That means one basic operation takes 1 unit amount of time. Okay, so this is the total time taken as per the frequency count method. Now we have to find the time complexity, which in short form I can write as TC. So basically, as we have seen in our previous video, there are some rules to find the time complexity. Okay, so we will actually discard the constant which are in addition, subtraction, multiplication, division. Okay, we will discard those constant. So here you can see this 2 is a constant term. So basically we will discard this 2. Okay, so what will be remaining after this 2 is discarded? 3n. And here you can see if constant is in the multiplication, that will be also be discarded. So this 3 will also be discarded. So we will be left with n. The time complexity will be n. And as you know, we write the time complexity in the asymptotic notation, okay, as we are following the asymptotic analysis method. Okay, so I will say that time complexity is big O of n. So if you are not sure that what is this big O, okay, so I will actually discuss this in the upcoming videos where I will discuss the asymptotic notation. Okay, for the timing you can just say this is order of n. Okay, so you can say time is changing for this program as rate of n. Okay, that is linearly your time is changing for this algorithm. So this is the time complexity. Okay, so this is the function, this is big O of n. You can say in mathematics you can write this is a linear function. Okay, so linearly your time is changing. Okay, now let's find the space complexity for this question. So space complexity, as I have discussed in the previous video, it means that how much extra space in the main memory is being taken up by your algorithm, okay, during the execution, right? So as I have explained in the previous video, that extra space means that we will not count the space taken up by your original code and the original input. We will count the extra things or extra data structures that you have taken in your problem, okay, or in your algorithm to solve your question. Okay, they will actually account for the space complexity, right? So you can see here we have the main memory. Okay, the instructions of your, you can say, code will be, you can say, kept here. Okay, but they will not account for the space complexity. The things which are present here, and present here, they will be actually taking part in finding the space complexity. Okay, so as you know, space complexity is constant space plus some auxiliary space. Auxiliary means extra space. So the space taken here, taken here, taken here by your code will be called as auxiliary space. Okay, so in this code snippet, what will be the space complexity? Let's say we have the main. Okay, let's say we have the main function. So this I equal to 1 is a normal variable. So this will go into the stack part, right? Stack part of the main function. Okay, now what are the other variable? We have the variable n. Okay, again it is declared, let's say, inside the main. Okay, let's say we have the int I n. Okay, so this n will be here. Okay, okay, and this I plus s is a executable statement. Okay, and this is a statement. Here we are assuming that here we have some executable statement which actually takes 1 unit amount of time. So we have these variables which have taken the space. Okay, so what will be the space complexity? So actually let's assume that this I and n, they are the integer type variable. So that means how much space will be taken by them? So I will take 4. Okay, 4 byte, and again it will take 4 byte. Okay, plus, is there any other extra space? There is no any other extra space, so we will not add now. Okay, the total 4 plus 4, 8 byte space are being taken up by this code other than the code section. Okay, this is not counted in the space complexity, right? So basically space complexity will not be 8 byte. This is the, you can say, exact number of bytes, okay, which are actually taken up by you can say code. Okay, space complexity will be, as we have seen in our previous video, that if there is, you can say, constant space, then we will say that the space complexity is order of 1. Okay, this big O is order of big O 1. So this is telling that the space complexity of your code is constant. Okay, even if you write order of 8, that will also be equal to order of 1. Okay, that we have discussed in our previous video. So basically space taken up by your this code is not changing with the value of n. Okay, even if n is 10, again this space will be 4 plus 4, 8 only. If n is, let's say, 10 to power 3, then also this space will be 8. Okay, so that means space complexity will be not affected with the changing value of the n. So space complexity will not grow with the n it will remain constant. Okay, so you can say space complexity is order of 1, that is constant. So you can say every space was constant. Actually, was no auxiliary space, though no extra space was taken. Okay, so in the asymptotic notation we will discuss in the further videos also, we will actually not take this constant space into account. Okay, we are actually concerned about the space which is actually changing with the value of n. Okay, so basically there was no as such space which is changing with the value of n, so we got the constant space. Okay, now before ending this video, let me ask you one simple question. Let's say this loop is starting from I equal to 0 and this line is same, I less than equal to n. Then what will be the time complexity of this iterative code? Basically time complexity will remain same. Okay, only this thing will be affected. Okay, so basically in the previous code where I was starting from 1 to n, okay, so it is like 1 is here, n is here, so value was starting from 1. Okay, we are starting I from 0. Okay, so it will take more number of steps to reach n with comparison to when I was 1, right? So basically I equal to 1, it will be basically this statement has been changed to I equal to 0. Okay, so this will be like done for the one time only. Okay, and I less than n, how many times this will be done? So basically as I is starting from 0, okay, so basically now I less than n will be executed n plus 2 time, one extra time, right? And the same way I plus plus will be executed n plus 1 time, right? If I is starting from 0, the total 1 is added here, 1 is added here. So total count of 1, n plus 2, n plus 1 will be, this is n, n, okay, and this I plus. So before ending this video, let me ask you one simple question. Let's say I is starting from 0 instead of 1. Then what will be the time complexity? So basically time complexity will remain same actually. How? So basically if I is starting from 0, okay, so you can say I is starting from 0 to n, and initially, or you can say previously, I was starting from 1 in the previous code. So it will take more number of steps to reach n from 0, right? So basically if I equal to 0, this statement again it will execute only 1. But if I is starting from 0, okay, then this statement will be executed one more time. It will take n plus 1 plus 1, that is it will be executed n plus 2 times, right, from 0 to n. The same way we have the I plus plus. Okay, so this will be again executed one more time, will be executed n plus 1 time, and this statement again it will be executed one more time. Previously it was executed n time, now loop will be true for n plus 1 time. Okay, so basically total number of, you can say, steps or the frequency will be 1 2 3 3n, okay, and 2 1 3 4 5. Okay, so 3n plus 5 is the total number of steps. Okay, so basically 3n plus 5 is total number of steps, so time taken will be 3n plus 5 into 1 unit. Okay, because one step take 1 unit amount of time. Basically this is 3n plus 5 total time taken, right? So this much of total time will be taken on the CPU for all the statement execution. Time complexity will be, see, you can remove the constant. Okay, you will discard the constant 5 and you will remove this 3 also. So basically we are left with n. So basically time complexity will again be order of n. Okay, so that means this constant can be discarded and there will be no change on the complexity, time complexity, because this is just telling me the order of growth, at what rate my time is changing. Okay, so yeah, I hope you have now understood about the time and space complexity. We'll take another example in the next video. So see you in the next video. Till then, goodbye.